Right. So in our previous lesson, we had introduced the manager class, which is basically a subclass of the employee class, right? So we actually discussed how you can reuse existing code or functionality which is in the superclasses. So we said each and every subclass, by this concept of inheritance, it acquires the features of the superclass. It acquires the features of the superclass, and then in addition to the features which are defined in the superclass, it will have its own distinguishing features. And by features, we basically refer to the state and behavior of objects within a class. Right. We had actually introduced some methods in the manager class, right? And we had also invoked some of the methods which are defined in the manager class by simply instantiating the manager class to get a manager object, and then we applied that manager object to methods which are defined in the manager class, as well as methods which are defined in the superclass employee, because we indicated that the moment you define a subclass object, if you define a subclass object, you can actually apply methods which are defined in the class of that particular object, as well as methods which are defined in the superclass, right? So if there are some other methods which are defined in the superclass employee, right, which are not defined in the subclass, I think we have examples of such methods. For example, we have got the getName the getName method, which is only defined in the superclass, but it's not defined in the subclass, right? But what we are basically saying is that through the concept of inheritance, we can actually reuse this functionality by just using the subclass object. So I can actually come here, and then I call the getName method, which is defined in the superclass, but using a subclass object. Could you please tell those guys that they are making noise? Right. So let's maybe just look at some concepts relating to what we have covered. Right. Here we are just demonstrating that maybe you can actually invoke methods from the superclass using a subclass object, and there is a print method. Even though in our class we didn't include a print method, this is how you can include a print method. There's already a print method which is defined in the superclass, which prints the name, salary, and the secretary name, right? So we now want to override the one which is defined in the superclass. So for us to do that, we define a method with the same signature as the one which is defined in the superclass. It is supposed to have the same signature. Let me just check if I have. It's not in this handout. It's in the other the first handout. That's where we have the declaration of the declaration of the print method. But that print method, which is in the employee class, it prints the name, the salary, and the name of the secretary, right? So what we are basically saying here is we are using the keyword super to invoke the print method which is defined in the superclass, right? Such that it prints the name, salary, and name of the secretary. Then in addition to that, we then print we then print what are we supposed to be printing here? The additional is the secretary's name. Sorry. So I was saying something that is not very correct. So the one which is in the superclass, it allows us to print what the name and what and the name, salary and hire date, name, salary and hire date. Then we are now calling that one, and then it prints those three attributes. Then in addition to that, we then print the name of what? The name of the secretary, because that's the only what? That is the only attribute which is unique to this one, to this manager class. So that's how you reuse existing functionality. So this is called what? This is called overriding. This is called overriding. Let me just check in my class which I defined if I have got maybe one method which is overriding another one in the superclass. Right, I have got this read method. I have got this read method, right? What this read method does is it starts by invoking the what? The sRead method which is defined in the superclass. So if I go to the superclass, I have got an sRead what method. Where is it? Right, here is the method. So this method allows one to read the name, the salary of what? Of an employee. It allows one to read the name and what? The name and salary, right? We should have maybe just modified it so that we could also read the what the date. But what we are now doing is we are redefining or defining another method with the same signature in the subclass here. So this is what we are referring to as the method what? Method signature. The name as well as the list of formal parameters, right? So we are going to define a method here in the what? In the subclass, and that is the method with the same signature, and then we start by invoking the sRead which is defined in the superclass, right? Then after that we read what? The name of the secretary. We read the name of the secretary. So what this basically means is that this sRead method defined in the subclass manager, it overrides the sRead method which is defined in the superclass employee. And this is what we've been calling dynamic polymorphism. That is dynamic polymorphism, where you have an inheritance hierarchy, right? And then you define methods with the same signature in the sub and super classes, such that the ones which are in the subclasses they override the ones which are in the super classes. That then becomes what is called dynamic polymorphism, right? So it is called dynamic polymorphism because when we come to the test bed here and then maybe try to invoke maybe the bread or the sRead method, right? If we try to call that method, the decision to bind the appropriate method to this object, it actually takes place during what? During execution time as opposed to compilation time. That is the reason why we are saying it is what? It is a dynamic polymorphism. So this method sRead is a polymorphic what? It is a polymorphic method, or a method with maybe different forms, right? Poly means many. Formism means maybe something to do with what forms or shapes. So this is a kind of a method which is various forms. It's a method with various forms. So that decision to bind this interface to the actual implementation, it takes place during what? During runtime. But as we are all aware, when the Java virtual machine is executing this file, when it comes across this statement, what happens is that it will then switch control to the place where this method is defined. So that is where what control is what is passed to. So it will then check the type of argument which is being used to call the to call the method. Then it will go to the class of that particular object. This is a manager object. So it will come to this class. Then it will check if there is any sRead method, right? If it finds one, it will then implement it. And we are saying that decision to bind the method interface to this actual implementation, it takes place during runtime. It takes place during runtime. So what I was saying is that if it switches control to this file, then it will search if there is any sRead method which is defined here. If it doesn't find any sRead method, it will check up the inheritance hierarchy, starting by the immediate parent of immediate parent of manager, which is employee in this case. Check whether there is an sRead method which is defined. If there is one, it will then It will then bind that interface to that actual implementation. So control is transferred to what? Control is transferred to that particular stub, so that it can It can run, right? If it doesn't find the sRead method in the immediate parent, it will continue to search up the inheritance hierarchy until it gets to the ultimate superclass of all the classes in Java, which is object, right? If it doesn't find any definition of an sRead method, it throws It throws an exception. Method may be not found or not defined, right? So this is how methods are actually involved, and how this concept of polymorphism are actually work. You really need to understand these concepts: inheritance, polymorphism, abstraction. These are the fundamental concepts when it comes to object-oriented programming, right? So it's not only about maybe writing code which can maybe give you results, but it's also important to understand the theoretical aspects or concepts, right? Should be in a position to actually maybe using an example explain or demonstrate these concepts that we are talking about: dynamic and static polymorphism. What does it really mean? How does the code run? Because the type of binding, it has a bearing on the efficiency of your program. There's a bearing on the efficiency of a program. So you really need to know the type of binding which is going to take place, whether it's static binding or it's dynamic binding, right? Static binding is known to be efficient because it actually uses direct addressing, as opposed to dynamic, which uses indirect addressing, which is not that efficient, but it is flexible. It is flexible, right? I think that's all about maybe the concept of inheritance. Let me maybe just quickly go to that handout and just check if there are any other issues that I have not maybe talked about. This is just a recap of what we have already covered. Like I indicated, these concepts are very, very important. Polymorphism, right, which we are saying it refers to several forms, like I have already indicated, right? So we have got two types of polymorphism, like we've been saying. We have got dynamic polymorphism and static polymorphism, or maybe compilation time polymorphism, as opposed to a runtime polymorphism. So if you look at, I think I indicated this in one of our lessons. If you look at the constructors, if you look at these constructors, right, the no-args constructor and the one which takes arguments, right? So here we are overloading the name employee, or we are overloading the method employee. We can have the same name but different formal parameters. Same name but different formal parameters. So when you are in this test bed, the moment you say new manager, it will switch control to the what? It will switch control to the constructor, the manager constructor, right? And we are saying this kind of a decision, it takes place during compilation time, as opposed to what? To invocations of what? Of our methods, right? Where maybe there is overriding of what? Overriding of methods, right? So what we are basically saying is that this decision to bind maybe this object to the actual what? To the actual constructor, it takes place during compilation time, because that constructor is simply what? It is simply overloaded. It is simply overloaded. So with overloading, we are saying we are defining a method with the same name but different what? Different signatures. If it is now overriding, we are now saying there are two classes which are involved, and these form two or more classes which are involved, which form an inheritance hierarchy, right? And then we are saying there are the methods, a method with the same signature is defined in what? In different classes within that inheritance what? Hierarchy. That's when maybe we can begin to talk about overriding as opposed to overloading. Right. This is just a recap. So some maybe points to note. So we are saying overload resolution takes place entirely at compile time. You cannot overload methods with methods differing in return types alone, but it's not supposed to be only return types, but also the signatures. Right? We cannot overload methods with the methods differing in exception specifications alone. For overload resolution to succeed, you need to define methods such that the compiler finds one exact match. And that can only be done if you define methods with the different formal parameters. Right, then here we are also saying that there is a principle, which is one of the relationships which exist between classes, which exist between classes. When we talked about what? When we talked about class diagrams or UML modeling, that is one of the concepts or a type of relationship that normally exists between what? Between a superclass and a what? And a subclass, where we are saying a subclass is a what? Is an object or a member of what? Of the superclass, right? So we can always assign an object of the subclass to a variable of the superclass. So a superclass variable is polymorphic. A superclass variable is what? Is polymorphic, right? So what we are basically saying here is that here we are saying manager M is equal to new manager, right? So we are saying we can assign a superclass variable to a subclass object. We can assign a superclass variable like E. We can assign it to what? We can assign it to M, like that. So we are saying this E is of type what? It is of type employee. We are assigning it to what? We are assigning it to a manager object. But the subclass object is always what? Is always a superclass object. But it's a subclass or a child of what? Of the superclass. I think I've already indicated in our lesson that when you are looking at what I've highlighted there, the data type and the what? And the variable, we have been saying that when you are talking in terms of objects, that E is not the actual object, but it's just a pointer or a reference to where the actual object is stored in what? In memory. So some might begin to maybe wonder how can we maybe store a manager object with four maybe parameters or arguments in an employee variable with only spaces for three arguments. If you think it that way, you end up maybe being lost, it's actually possible to assign a subclass object to a superclass reference. And here, you don't need to do any typecasting. Don't need to do any typecasting. Because a subclass object is a superclass object. Right? But if we were to try to maybe say manager, maybe P is equal to what? Is equal to E. Like that. Right? As you can now see, it is now already complaining. It is now already complaining. Let me maybe check if I can get the correct error message. Here saying type mismatch cannot convert from employee to manager. So we have somehow maybe managed to confuse the compiler. Because here we are saying M is a manager object. That we are assigning to what? That we are assigning to an employee reference, which is a superclass. So E is now pointing to what? To M. Or these two are now what? Are now aliases. They are now aliases. M is pointing to this object. Because we are saying this is just a what? This is just a reference. And this is also a reference. Right? So this is the actual what? This is the actual object. When you say new, then you define the what? The constructor and pass arguments. The actual arguments. That's when the object is actually created on the heap. After creation of the object, it retains the reference or address of where the object is stored in memory. That reference is what this variable will be storing. That's why we normally call them reference variables. Right? So here we are now saying E is equal to what? Is equal to M. But here we define a manager what? We define a manager variable P. Then we try to assign it to E, knowing very well that E is pointing to what? Is pointing to a manager object. But we are now getting an error. So what we now need to do is we now need to do typecasting. We now need to do typecasting. So we can simply do this. We do typecasting. Everything is now what? Everything is now fine. So if you look at this, it is also a polymorphic what? It is a polymorphic variable. Every superclass reference variable is a polymorphic variable because it can actually point to an employee object. It can also point to what? To a manager object. Therefore, it's polymorphic. Are we together? Or have been disappointed about the test? Right. Is that a question? Yes. Shh. Can you be quiet, please?
I thought maybe methods, only methods are supposed to be.
Even variables, they can be polymorphic.
So I just want to know the
Both we are saying here the superclass variable E. If I can say employee here, employee, maybe E what? E1 is equal to new employee. Right? This employee reference variable E1, it is actually pointing to an employee object. Right? Here I have actually demonstrated that you can also what? You can also assign this reference to a subclass object M, or I can actually do it directly. I can actually say employee here, like this. Employee M is equal to what? New manager. So each and every reference variable that you define for a superclass, it can point to either an object of its own class or to any object of what? Of its subclasses. That is the reason why we are saying it's polymorphic. Another question? Right, so this is maybe the concept that we are explaining here, where we are declaring these variables, where we are saying E1 is equal to new employee, then E2, then M1, M2, and so on and so forth. Right. This concept of polymorphic variables is very, very important when it comes to arrays. Because you can actually declare an array of that superclass type. That array can store objects of the superclass and also objects of what? Of the subclass. Right? And then it allows you to maybe again use the concept of polymorphism. Let me maybe just demonstrate what I'm talking about here. What were the formal parameters in the employee class? Let me maybe just define an object with the actual details here. We have name, salary, and all those. Didn't I define 3 constructors here? Or it's in the other class? Employee. Yeah, I think I can maybe use this one, which doesn't take a lot of parameters. So there I have got name, salary, and date. Name, salary, and date. So what I'm going to do is I'm going to create an employee object. All right, let me convert this to a manager object. And I already have that date. Right. I already have that date. Maybe I can just use the same one, the same date. Right, then I say employee E is equal to, maybe let me just copy this, paste, and then maybe take these arguments up to here. Because this one, it takes name, right? That's the name, the actual parameter. Let me maybe change the name. Right, then that's the salary. Right, then we have the higher date. It can be the same. Right, then I can declare another what? Let me just copy these 2 and paste them. Then I just change the attributes. But you can leave them like that. Then maybe 1 here, 1 there, 2 there. Then the other details. Salary and so on. I'm going to leave all these other details. I'm not going to change them. Right. So what I can now do is I can now create an array. Because here I've got manager objects and employee objects. And I want to store these 2 types of objects in an array. One array. I want to store these objects in an array and one array. So I just declare an array of what? Of employees. I declare an array of employees. Maybe I can just call it EA, like that. Then is equal to. Then I can maybe use this shorthand, M, E, M1, M2, E1, E2. I'm done. I now have an array. Right? So this array is storing both superclass and subclass subclass objects. Right. After this, I can actually use the advanced for each to iterate over the over the collection, fetching one object at a time, and then maybe you can apply whatever methods that you have. It could have been maybe better if we had maybe defined a print method, so that maybe as we are fetching the elements in our collection, we can just print. So what I can do is maybe I can quickly provide a print method in both classes. Right, let me go to employee. Right, then I just want to provide some methods here. All these methods which doesn't maybe work for the manager objects, they have to be we have to override all the methods which are in the which are in the superclass, which can't be applied maybe as they are to objects of the subclass. Just need to go and override them in the subclass. I didn't do it with all. These methods include the equals. But this equals method, when we defined it, we could only compare I think it was the name and salary. We later on introduced the higher date. We didn't modify the methods. And then we have got We have got the toString. I think it was only returning salary and name. Then we had the read method. They were only allowing us to read only those two arguments, right? So we should have updated all these methods when we added or introduced that additional attribute, the higher date in employee. So here what we want to do is we just want to have a print method. This method does not maybe return anything, just printing. So what we can do is we can simply say print what? Just want to print system.out print line or print want to print the name, and then we also want to print the salary, then the date. Those are the three objects that we want to print from here, right? You can define it in various ways. Maybe I can define mine as follows. Do I have the getter methods? I can say this dot get name like that. Then plus, I just want to maybe print the actual details. I'm not worried about maybe the formatting. So this dot get salary, right? Then after that, I have the higher date. The higher date, we didn't define a get method. So what I can do is I can just use the higher date here. I can say this dot this dot higher date like that. Maybe I need to separate these two with a space, so I can maybe just put a plus there. Then I have a space there. Then another plus there. Or I can actually use a tab a tab space if I want, like that. So this is now the print Huh?
Here repeater dots get.
Or get salary. Oh, thanks for that. This is supposed to be get name. Anything else? Yes? Yeah, we could have done that. We could have done that. That's another suggestion which is coming from. So he's saying instead of defining it to what, a print method, we could have maybe just used our toString method, because we indicated that if you define a toString method, it will allow you to print objects as what is string arguments, which is a brilliant idea, right? So we now have this method, right? Then maybe I'm going to add another one in the subclass, public void print, right? So what I then need to do is I need to call the one which is in the superclass. So I start by saying super print, right? Then after that, what I now need to do is what? Is to print the name of the secretary. So I can say system.out_println. Right, maybe I might need to go and change the one which is in the superclass side that those details are printed on one line. Then it will merge with whatever we are going to print from this method. It's what here? It's this dot. Sorry, it's not supposed to be in quotes. Dot. Did I define a get here? No. So I can just say secretary secretary name, like that. Right, so what I was saying is that I can come to this class and then maybe remove that ln, right, like that. Then maybe after the last one, or maybe in this method, I can maybe start by having a tab. If I put it here, it might maybe have a problem. If I call it using a superclass, a superclass object, was it to print a tab space which we might not need. So what I might need to do is I might maybe need to have a tab space here before I print the actual name, right, like that. Right. So now I have got that print method. I can now come back to the test bed. Right. Then I have my for or advanced for loop. You can use that ordinary loop if you want, but it's better maybe to use this advanced for loop. So I say for, then I declare what? A variable of type what? Of type employee, right? I can maybe call it v, then colon, then I specify my collection. I specify my collection. Then what I simply need to do is to say v dot what? V dot print, like that. Right. So when this code is what is executed, what happens is that since here we have a data structure with a mixture of super and subclass what? Objects, it really has to know the type of what? The type of object that V is pointing to. Was V can either be a manager object or it can be an employee object, right? So if you look at this kind of data structure that we defined there, the first object is what? Is a manager. So it is supposed to invoke the print method which is in the manager class. Then after that, the next object is now an employee, which means that it is now supposed to invoke the what? The method which is defined in the what? In the superclass. Then after that, the next object is a manager. Next one is a manager. So it means that it is going to invoke the what? The print method defined in the manager class twice to print M1 and M2. Then it will to invoke the print defined in the superclass twice to print E1 and E2. Right? So like we have been saying, this decision to determine the actual method to be invoked, it takes place during runtime. And that's what we are calling what? Runtime polymorphism or dynamic polymorphism. Right. So if I run this, I expect it to call the appropriate methods depending with the object that E is pointing to. If E is pointing to a manager object, it's supposed to invoke the what? The method which is defined in the what? In the manager class. Otherwise, it invokes the method which is defined in the superclass. Right? So, if I run here, right, this is the output that I get. This is the output that I get. It knows which object V is pointing to, and then it will call the appropriate method. Huh? You want to see the output? Why? Tenda waona. Right, that's the output. Right, so you can actually define an array. You can also use this kind of a loop, and then you use those loop control variables. And I don't think maybe you might need to use that approach, but I've actually demonstrated how you can do that. And then here we are now maybe just checking whether the value which is stored in our variable E is either an employee, or because we said an employee reference variable is polymorphic, right? Yes. Yeah, runtime. You invoke it, but the time when it is going to be given control to implement, or the time it is, because when we are talking about polymorphism, we talk about it in the context of what is called binding, which in programming language is just maybe an association of one entity to another entity. If you maybe look at you cover some of these concepts in your programming languages course. But if you look at maybe a variable, just any variable, like let me go to the top part of if you look at a variable like this string name, there are quite a number of things which are involved here. We have got the variable name. We have the variable name, which is name in this case, right? It is being associated with a what? With a type, or it is being bound to what? To a type. What time is the variable name bound to the data type? That kind of binding in Java takes place during what? During compilation time. Takes place during compilation time. We also have this variable and the memory cell that it is associated with. What is the time at which that kind of an association or binding takes place? If there are primitive variables like these ones, in most cases binding is what? Is static, or it takes place during what? During compilation time. When you invoke a method, we have got the method interface and the actual implementation of the method. At what time is that binding effected? When is the interface bound to what? Bound to the actual implementation of what? Of the method, so that it can actually what? It can actually run. It can either be static or it can be dynamic. If you look at the way that we call static methods, because we said that there are two types of methods in Java. We have static methods and non-static methods. When you are calling a static method, you use the name of the class. That's the way we've been calling maybe methods which are defined in the math class. By simply saying math dot square root, math dot power, math dot sine, math dot sum, mean, max, and so on. Because those methods are static. So when binding takes place, it takes place during what? During runtime. So during compilation time. Because it's static. It takes place during what? During compilation time. Right? But when you are calling a method using what? Using an object, that is the kind of binding which takes place during what? During runtime. And that's runtime what? Runtime polymorphism. That runtime polymorphism, it is known to be flexible in the sense that when objects are, because here, let me go maybe to an example where we have an object. Right, we have got these objects. They are created at runtime. These objects are actually created at runtime. When you say new, right? When that object is created, it is stored in what? In memory. Right? And then it can actually be what? It can actually be destroyed before maybe the program is finished execution. Such that that memory cell can be what? Can be reclaimed and used by another what? Another object. But if it is static, what that means is that one entity is associated or one entity is bound to another entity at what? At compilation time. And it remains bound throughout what? Program execution. Unlike if it is what? If it is dynamic, which can actually change during what? During runtime. Memory can be reclaimed and used by other what? Other objects. But if it is static, the moment a variable is associated or bound to a memory cell, it remains bound to that memory cell throughout program execution. We'll talk more about these issues when you do your programming languages course. Yes. Like what? The two string. They are called at runtime. They are called at runtime. I think I mentioned this in one of our lessons that when you define where is the toString method? I think I indicated that when you define a toString method, where is it? Right, when you define a toString method like this, right, you don't need to call it explicitly, right? From maybe the way the language was designed, it was designed in such a way that what you just need to do is to make sure that you define it, right? When you define it, the moment you pass an object as an argument of the print or print line method or any print what method, it will automatically invoke what? The toString method. You don't have to want to explicitly invoke it. The moment it comes across or it sees maybe an object as what is an argument of a print method or print line method, it will check where is this object defined, or what is the class of that particular object. They need to go and check for a toString method. If it finds one, it implements it. If it doesn't find one, it will go up the inheritance hierarchy until it gets what or finds a toString method. If it doesn't find a toString method, that is the reason why you end up seeing it printing maybe the address or didn't I demonstrate this in one of our lessons? Yeah, it's actually a method which is defined in the application programming interface. It's in the object class. Let me open for you some of these classes. System.out.println. Then I print what? Let me try to print E. I've got E. The toString method is only defined in what? In the superclass, but I can actually apply the subclass object M. But what it is going to do is going to print only two fields, because the one that we defined, it only has 2 fields. So let me maybe just comment out this, because that's not what we want to see. Right, so if we have something like this, then I run. Right, so as you can see, I don't know if you can see, what can I do? It's printing those details at the bottom of what, at the bottom. Maybe let me copy them to this application. This is the output that I'm getting, right? So it's just printing the name and what, the name and the salary. I think there's maybe just a formatting issue with our toString method, which is not a big a big issue here. It's after what? After here. We are maybe supposed to. Is it here or before? It's here. Sorry. Yeah. Maybe after this or after. We are supposed to have what? Supposed to have a space. Or maybe I can put a space there. Like that. But if we now, as you can see, here we used the subclass object. We passed the subclass object as an argument there. But if I go to the manager class, I didn't define any toString method. So what has happened is that it has invoked the one which is in the superclass. The one which is in the superclass, it only prints 2 arguments, the name and the salary. So that's the concept of inheritance, because we are saying a manager extends the employee. So it has the privilege of maybe accessing all the functionality which is defined in the superclass. You can just invoke as if the functionality was defined in the subclass, right? But the moment we remove this toString method, or if I maybe just comment it out, right? So if I do this and save, and then I come here and then I compile, right? This is now what I'm getting. This is the output that I'm now getting, right? So that toString method is very, very important. You need to make sure that if you are going to ever have a situation or a scenario where you are going to maybe print objects or pass them as arguments of the print or print line method, you need to make sure that you always provide a toString method. There is no harm in calling it explicitly. You can call it. Nobody can actually prevent you from calling it. But it doesn't make any sense. Oh, sorry. You can call it like that, and then you can run, and then you get the same output. But it doesn't make. It's not necessary. No. What we are saying is that we are overriding a method. Oh, I had maybe forgotten to show you this method. Let me maybe just come to, I can maybe use any class here. Let me just declare an object here. Object, maybe P. Right, what I just want to use this is to extract, to get this method is defined here in the object, which I've been saying that this is the ancestor of all the classes in Java. All the classes in Java, they implicitly extend object. They extend object. Let me search toString. Is this right? This is the toString what? This is the toString method. And this is what you were getting, because it was invoking the toString method. Because I think I indicated that if you call a method like this, if it doesn't find the method, it will search up the inheritance hierarchy until it gets to what? It gets to the ultimate superclass, to the ultimate superclass object, right? So this is what happened earlier on when I removed that toString method. You saw something with an 8 character and then the X code of what? Of that particular object. This is the method that was invoked. That's the method which was invoked. Because it searched for the toString method in the manager class. It didn't find one. Then it searched in the employee class. It didn't find any toString method. Then it continued to search up the inheritance hierarchy until it got to what? It got to object. That's when it found what? This toString method, and then it what? It implemented it, or it executed it rather. And then just printed the what? The class. That's why we had something. I think I still have the output. That's why we have got something like this. So it's just calling this get what? Get class dot get name. We want to know the name of the class. Then we are saying it, then integer dot what? Then we have the hexadecimal what? Hexadecimal hash code. Right? You didn't cover hash tables in data structures. That's another very useful data structure. I hope I'm not the one who taught you. Yeah, but it's just an advanced data structure which is very, very important. It's actually useful in what? In our computer science. You need to go and read about hash tables, hashing, and so on and so forth. Right, I think we can maybe have a short break, then we continue.